quadratic equations. So what we looked at before, linear equations, now we look at quadratic equations. These are the two main type of equations, and why are they important? Because every polynomial can be factorized down to be a combination of linear and quadratic factors. So these two types of things, linear, quadratic, are very, very important. So woohoo! And there's the basic idea of quadratic equations. You see, if you've got things multiplying together to give 0, the one of them's got to be 0. It's the only way you can get that as an answer. That's the key idea. So we want to factorize. So we've got a multiplication of factors. Simplifies the question because linear equations very easy to solve. So there's our quadratic. Multiplies together give 18. Adds together give 9. 6 and 3, well, one of those things has to be 0. So either x plus 6 is equal to 0. We don't normally write it down because it's a very simple equation. You can do it in your head. That's x is negative 6. Or x plus 3 is equal to 0. X is equal to negative 3. Got to be one of those things. Now I'll put this one down just to highlight something, because amazingly, how often people forget the x out the front and just solve the 2x plus 1. But x is a factor as well. So it is a possibility that x equals 0 and the other one x equals negative a half. Patterns, I said. Patterns. If we can find patterns, it makes life easier. Well, quadratics, we solve them the same way every single time, which means we can create a formula. We can find a pattern. And there it is. X equals negative b plus or minus the square root of b squared minus 4ac all over 2a. Lovely formula. So we get a question and we look at it. Now, it might factorise, but I don't want to take a lot of time. So if I'm struggling to work out what the factors are, hey, I'll just go straight to the quadratic formula. It's going to get me the answer. So let's sub it in. Negative 5 plus or minus the square root of 25 plus 32 all over 4, or 25 and 32 is 57. Thank goodness I didn't spend a lot of time trying to factorise it, because no, this one wouldn't have factorised because we don't know what the square root of 57 is. But there's our two answers. Negative 5 plus the square root of 57 on 4 and negative 5 minus the square root of 57 on 4. We tend to leave it written that way rather than write it as 2, but I mean there's no drama if you want to write it as 2. That is what we call an exact answer. So whilst we don't know what the square root of 57 is, that is the exact answer. Best we can do if we want to come up with a number is something like this, and that is just an approximation. It's not exactly what the answer is, but yeah, it gives us a pretty good idea of what the answer is. Make x the subject in this one. Essentially, this is solving a quadratic equation. I want to make x the subject, but for this, if x is the subject, so everything is with respect to x, and as far as I'm concerned, any other pronumeral that's there, I treat it like a constant. So I rewrite it so it looks like a quadratic equation. X squared plus 4x minus, and then the constant number becomes 3 plus y. I'll just put that into the quadratic formula. Negative 4 plus or minus square root of 16 plus 4a, which in this case is 1, c, which is 3 plus y, all over 2. Tidying up that surd, 4 goes into both 4 and 16, so I can pull that out of the surd. Square root of 4 is of course 2. I'm left with 7 plus y. 2 will go into everything. There it is. X is negative 2 plus or minus the square root of 7 plus y. X is now the subject of that particular equation. Okay, there's quadratics.